Predict the electrical energy output of a combined cycle power plant. So to help us predict the energy output, there are four features that we have used: the temperature, ambient pressure, relative humidity, exhaust vacuum. And before getting into the modeling phase, we have run some exploratory analysis on these variables, which gives us an overall understanding of how these variables are individually distributed. We have also checked the correlation between our target variable and each of the four features that will use. And we have used scatter plot to understand how strongly they are correlated. So the average temperature shows the most significant correlation. It shows a very strong negative correlation with the target variable. And the vacuum has also a decent correlation with our target variable, whereas the average pressure and the humidity, they are seemingly they have weak correlation, somewhat positive, but weakly correlated with the target variable. So this approach is split into four broad steps. So the first being splitting the data into train and test. So we have used a 90-10 ratio to split the data. 90% of the data will be used for training and 10% will be used for testing out the algorithm. We have used both linear regression and random forest model to arrive at the best set of predictions. And we have also used k-fold cross-validation to run on both the models that will help us evaluate the model performance very strongly. So now we'll talk about the model output that we have received, and we'll compare the output between linear regression and random forest. So first, for the linear regression, we have received the cross-validation scores, which are the R squared, or the amount of variation that we are being able to explain with the features. So looking at the individual cross-validation scores, they are between 92 and 93%. Whereas if taken an average of the 10-fold cross-validation score, it's around 93%, which is very good. The root mean square error is also another metric that we use to evaluate the model performance, which for the training set is around 4.5 and for the test set is around 4.3. Now looking at the same set of output from the random forest, we see the cross-validation scores have significantly improved from around 92 to 96. And the 10-fold cross-validation score is also around 96, which is again a significant improvement from our linear regression output. And then we have also compared the root mean square, which for the training set is 1.2, which is way less than what we are getting from the linear regression. And for the test set, it is also decently good. It is around 2.9. So looking at all these evaluation metrics, we can summarize that random forest will be a better algorithm to go ahead with for prediction of our energy output. Thank you.